Now in this quick video, we're not going to make any changes to formulas. We just want to tweak the custom number formats a little bit and give you some extra skills so that you'll know how to get great formats in your financial models. Let's take a look. Now the first thing for us to tackle is down here. It says frequency 1. Not very descriptive. What we want to do is we want to leave the 1 in there, but we want to custom number format it a little bit so it would display as, say, 1 months. That would be perfect. Let's pop into that cell, hit Control 1, and we're going to use the Tab key down to Custom, hit the Tab key again, and we're going to use the backspace key here to wipe that out. What we're going to put in is a 0, okay? And then we're going to put a space, double quotes, and then we want to type in months, just like this, and then double quotes again. And we can see up in the sample pane that that's going to display as 1 months, which is perfect. Now we can hit OK or Enter, and we've changed the format of that cell. So the neat thing about this is if we hit F2, we can see that there's just a 1 in the cell, but we have it displaying, so it's a little bit more descriptive now. Now let's get up here and take a look at these formats here. We want to make some changes there to make them look a little bit more professional. Now the thing about the way that these dates are formatted is it kind of looks like a lot of numbers all the way across, and it's not really evident that the payments are always happening on the first day. So to make it a little bit more obvious, we might want this first one to display as January 1, 2024, and then this one could be February 1, 2024. Let's take a look at how we could do that. And the great thing about custom number formats, which is what we're really discussing here, is that we have complete control over the formatting. Let's highlight all the way across these cells and hit Control 1. We're going to use the Tab key to get down to Custom, Tab key again, and we're going to use backspace to wipe out that format. And we're going to start typing, and as we do, let's watch the sample pane really closely up here. We're going to put in 3 M's for month, and we see that's going to appear as Jan, which is perfect. Let's put in a space now and put in a D for the day. So now we have January 1. Now we're going to put a comma, space, and then we'll put Y for the year. That looks perfect. Now before we forget, we want to put in a visible right bracket for spacing. So we're going to put an underscore, and then we're going to put in the right bracket here and hit Enter. Now, as you can see here, we had total control over how these dates were formatted. And now it's looking really clean because it's easy when we look across to see that these payments are always happening on the first day. It's really important to know these tricks for custom number formatting so you can use this in some of your models that you're building. Now, obviously, these changes that we're making are all individually fairly minor, but collectively they all add up and make a big difference in your work and can be the difference between a good model and a great model. Now let's jump ahead to the next video. We're going to look at stub periods. They often come up when you're doing financial analysis, whenever you're dealing with an acquisition, or sometimes when you're dealing with valuation work. Let's jump ahead to that next video. We'll see you there. Stub periods come up all the time when we're doing financial analysis. Stub periods essentially are synonymous with a partial period. For example, if a company's reporting every 12 months, then if we needed to look at a 9-month period, we would refer to that as a partial period or a stub period. They're very common when it comes to valuation work and also when you're looking at acquisitions. Let's jump in and take a look at how they work and also a particular date function, which is perfect for calculating stub periods. So let's start off by looking over here at the fiscal years. And as you can see, we've labeled them really clearly, and they're going to be in year, month, day format. Now let's assume that the company will report its next fiscal year at the end of 2024. So in here, we're going to input 2024 and then 12/31 and hit Enter, just like this. Now, the company will usually do its next fiscal year end exactly 12 months into the future. So this next date here would be 2025, 12/31. So to get that date, we could use either EO month or EDate. In this case, let's try the EDate function. So we pop into this cell and say equals EDate, hit the Tab key. It's asking for the start date, which is right here. Put in a comma. How many months forward? We're going to go 12 to get a year, and then we hit Enter. And now what we can do is copy that, Control C, highlight all the way across here, and we're going to do Paste Special, Alt ES, or Control Alt V. And then we go down to Formulas and hit Enter, and that's been completed. Now let's look at our valuation date right here. Let's suppose that we were going to value this company as 2023, 12/31. If we were going to look at the value at that date, then there would be exactly 1 year between that valuation date and when the company reports its next fiscal year end. If we recorded the dates like this, we would have a full financial year between the valuation date and the next fiscal year end, which would mean we would not have a stub period because our spacing would be exactly 1 year here and then 2 years, 3 years, 4 years, etc. And we would have perfect 1 year spacing and no stub period. In fact, it's relatively common to not have perfect 1 year spacing between the valuation and the next fiscal year end, so we often have stub periods to deal with. Let's look at an example where we're going to put 2024-03-31, and this is going to be our valuation date at the end of March 2024. Now, if we were valuing the company as of this date, and then the next fiscal year end was as of this date, it would mean that we would have the benefit of 9 months of that fiscal year in our valuation. And 9 months out of 12 months of the year would be having the benefit of 75% of that first fiscal year. But how can we get Excel to calculate this for us? Well, in Excel, there's a function that's designed exactly for this purpose. It's called yearfrac. So it calculates the fraction of the year that we're dealing with, which is perfect in this situation. Let's take a look down here in this cell. We're going to put in equals, and we're going to type in year, and we can see it here, yearfrac. Let's use the tab key to open that up. It's asking for the start date, which is right over here. It's the valuation date. Put in a comma. The end date is going to be this date right here, and then we just hit enter. And as you can see, it's calculated that fraction of a year perfectly. 9 months out of 12 is 75% of the year. Now we can easily just select from here all the way across and do a Control R, which is a fill right. And as we can see, after the stub period right here, we get perfect 100% all the way across, indicating that there's a full year between every one of those fiscal year end dates. Now, it may be obvious to you what we're going to do next. Effectively, what we're going to do is take this cash flow profile here and multiply it through by these percentages. So we go into this cell and say equals this, multiply through by the cash flow, and then we're going to highlight across just like this and do a Control R, which is a fill right. So what does this really mean for our valuation date? Well, if we've set the valuation date right here, the end of March 2024, it means we get 100% of all of these cash flows here. But this particular cash flow here of 16 million, we only get the benefit of 12 million of that 16 million. The other 4 million has already passed, and it's passed behind us, so it doesn't enter into the valuation of the company. So whenever you're doing financial analysis, keep in mind that stub periods are relatively common, and they generally come up with valuation work or when there's an acquisition. When there's an acquisition, you can set the acquisition date here where you may be acquiring the company, and then you only get the benefit of the cash flows which occur after that acquisition date. And whenever you see the need pop up for a stub period, you generally want to always revert to that yearfrac function, which comes in really handy for calculating the percentage of the year or the partial year. I hope you've really enjoyed this chapter on dates. It's important to understand how they work. We want to be able to deconstruct a date into year, month, day, and reassemble it using the date function. We also want to be familiar with functions like EO month and EDate and yearfrac, for example, so we can use these whenever the situations present themselves. So let's jump ahead to the next chapter. We're going to take a look at returns and also calculating rates of return and net present value. Really interesting stuff, and also very, very common when you're doing any kind of financial analysis. Let's jump ahead to that next chapter, and we'll meet you there. Now, this final chapter of the course is particularly interesting and important at the same time. We're going to be looking at some of the output calculations that are really, really common when you do financial analysis. It's very common in financial analysis to either look at a net present value or an internal rate of return. So we want to understand exactly which functions we can use to do that, but also be aware of some of the pitfalls of using some of these functions and some of the errors and inconsistencies which can occur so that we can carefully avoid them. The other thing that we want to be very mindful of is the cash flow profile that we're trying to evaluate. In particular, we want to look at that cash flow profile and determine whether or not it's occurring at regular dates or irregular dates. The other thing to keep in mind when we're calculating the net present value is that it can be very dependent on the discount rate. In particular, we often calculate the weighted average cost of capital as the discount rate. We want to introduce to you a really nice function that you can use to easily calculate the weighted average cost of capital, or the WACC. As we mentioned, there's lots of important information in this chapter, and there's also lots of interesting material in this chapter. We can't wait to share it with you. Let's jump ahead and get started in the next video. As you can see here, we're on the last worksheet or tab of this particular file, the one called Returns. And we want to start by discussing the weighted average cost of capital, or WACC. WACC. It's frequently used as the discount rate when doing financial analysis. We want to look at a really easy way to calculate it using a particular function in Microsoft Excel. Now, as we look down here, we can see that this is referred to as the weighted average cost of capital. If we wanted to do a simple average of the cost of capital, we would be averaging the cost of the debt and the cost of the equity. If we did a simple average across these two figures, we would get 9.5%. Now we're going to be doing a weighted average cost of capital. So the debt capital is going to have a 15% weight in the average, and the equity capital is going to have an 85% weight in the average. Knowing that the equity capital is carrying such a heavy weight means that the answer should come out closer to the 11.5 than it is to the 7.5. So let's take a look at how we could do this. First of all, manually and mathematically. We could put an equal sign in here, and we could take this cost multiplied through by that weight. And then we could add in this cost and multiply through by this weight. And if we hit enter, that will in fact give us the correct answer. And as we can see, it is in fact closer to the 11.5 than it is to the 7.5, which makes sense since this is carrying a heavier weight. Now what we've done in here is correct, but it's not as efficient as it could be. If we tap F2, we can see that this formula is already a little bit complex, but imagine how much more complicated it would get if we had more line items. We'd have to manually enter a lot of cells in. Let's look at a different solution. So in fact, the sum product function is absolutely perfect for an application like this. Let's pop into the cell and put equals SUMP. And then we can see the function name come up, we hit the tab key, and we're ready to go. So array 1 is going to be up here. We hold down the shift key to select these two weightings. And then what we do is we put in a comma, and then it's asking for array 2. For array 2, we select this one here, again using the shift key, and then we can hit enter. And as we can see, we get the same result. Now, if we look inside here, we're obviously using the sum product function, but the name is a little misleading. In fact, every time you see it, you should think of product sum, because in fact, what it's doing is it's taking the product first, and then it's calculating the sum. So what do we mean by product sum? Well, the function is actually calculating the product of these two numbers, meaning it's multiplying them together. And then it's calculating the product of these two numbers by multiplying them together. Once it's calculated those two products, then it's summing together the results. So it's actually working in the sense like product sum, but the name is obviously sum product. So whenever you're calculating a weighted average cost of capital in financial work, definitely try using the sum product function. It's going to simplify things a little bit for you. So let's jump ahead into the next video, and we're going to use this result for the WACC in some of our analysis to calculate the NPV for the company. We'll see you there. So one of the first things that we want to make sure that we do when we're performing valuation work is we want to set the valuation date. We also want to communicate that valuation date really clearly to anyone that's reading the model. We can think of the valuation date as like our goal line. We effectively need to discount every cash flow back to that exact date. That date is very important. That's why we want to make it really clear for all the readers of the financial model. Now, in the last video, we calculated the weighted average cost of capital for the company. We're going to obviously use this in the valuation. So let's connect this weighted average cost of capital here down into the next section. Here where it says WACC, let's pop in here with an equal sign and connect up to this cell, and let's tap F4 and hit enter. So we can pull the weighted average cost of capital down there, and then we can do a copy and move across and also put it over here. We're going to use it in two places. Now that we've copied the weighted average cost of capital down, let's bring everything down into focus so we can focus on this area of the model here. In particular, we want to put a message right into this cell here. Now, our valuation date in this case is right down here. It's December 31st, 2023. We want to communicate that really clearly to the reader right in this cell with a nice little note. So what we want to do in here is use a concatenate function. We're going to type in equals CONC, and we can see concatenate come up. Let's hit the tab key and then open up that function name. Now we want to put in double quotes, and we want to put in here, we have assumed a valuation date of, and then put a space, close the double quotes, put a comma in, and then go and grab the date down below. Now we're going to put another comma. We're going to open the bracket and then say for both examples below, and then put a period, finish the quotes, and then close the bracket. Now we can hit enter. Now what's happened here is Excel has put that date into a generic number format. So we're just seeing right here the serial number that's associated with that date. So we need to get into that function now, and we're actually going to use a text function to change that format so it displays as we would like it to display. So let's pop into the cell and make a modification. We're going to tap F2. We're going to go over here, and right in front of this reference, we're going to put in text and open the bracket. So we're inserting a text function here. We go after this reference for B21, and we're going to put in a comma and then open double quotes. And now we're going to define the format that we want. We want to see MMMM for month. That'll be a full month name. And then 1D for the day, comma, space, and then YYY for year. Now what we can do is we can close the double quotes and close the bracket for that text function. Now we're going to hit enter. So as you can see, this gives us a really nice label to clearly communicate this important information about the valuation date. And what makes it even better, it's completely dynamic. Anytime we change this date here, this label will also change. We were able to pull in the number, but then we used the text function to put it into the exact format that we wanted to see with the full month, day, comma, and then the year. And an important takeaway from this discussion is that we always want to communicate information really clearly with those reading the model, since it will instill a lot of confidence in them. But what we also want to do is invest a little bit of time to make all of our labels and notes dynamic. So anytime we update the model, all of those notes and labels are going to update automatically. We'll see you in the next video. So what we have here is a situation where we have a cash flow profile. And there's all these cash flows that we expect to receive in the future. But what we need to do is we need to figure out what they are worth today as of our valuation date. And we're going to call that value the net present value, or the NPV. Let's jump in and start calculating the NPV. Now, we've already communicated really clearly that our valuation date is December 31st, 2023. And that is coincidentally the date of our first cash flow. So we could calculate, for starters, the NPV could be equal to that cash flow. For example, if this was the only cash flow occurring in our profile, then this would be the NPV. But there's obviously more to the story than that. So this is obviously the amount of capital that we need to invest at the valuation date. But now what we need to do is we need to figure out the net present value of all of these future expected cash flows here. We can do that with the NPV function. So let's pop in and add an NPV function now to the equation. So let's tap the F2 key. And what we're going to do here is now add in NPV. and we're going to open a bracket. The first thing that it's looking for now is the rate. Now, if we try to move, we're only moving in the cell. We need to tap the F2 key once more, and now we can go up and grab this rate of 10.9%. Now we put in a comma. Now it's asking where all of the values are, value 1, 2, 3, etc. We can select from this first cash flow here, use the Shift key to get all the way down to the last one, and then close the bracket and hit enter. So this is showing us our NPV here. And we can also calculate the NPV using the XNPV function. Let's give it a try. Let's type in equals XNPV, just like this. We're going to open the bracket. It's asking for the rate. That's the weighted average cost of capital. Put in a comma. Now it's asking for the values. Well, here are all the values here. Let's put a comma in, and now it's asking for the dates. And all the dates are over here. Let's close the bracket now and hit enter. See what we get. What we have here is a situation where we have two results that aren't matching. One of them must be incorrect. In fact, one of the things that we're going to see, and we'll discuss it in the next video, is that this calculation using the NPV function is incorrect. We're going to put this into strike-through font. We're going to recommend that you do this as well. So pop into the cell and hit Control 5, which gives you a strike-through font, just to indicate that this is incorrect. Now in the next video, we're going to jump ahead and we're going to talk about why this NPV function is incorrect in this case and why the XNPV is correct. We'll see you there.